Hi, in this video we will learn about matrix multiplication. To do matrix multiplication there are three steps that we should complete. So matrix multiplication in three steps. First one is that we have to check if we can multiply these two matrices or not. So this is I'm going to call a dimension compatibility. What is dimension compatibility? Two matrices can be multiplied to each other if this is the compatibility condition. If this doesn't work, then it means that we cannot, that the multiplication is not defined. The number of columns of the first matrix must be equal to number of rows of the second. In other words, if I have two matrices A, B, we want to multiply them, then the first one has m rows and columns, and the second one has k rows and L columns. The two close by indices must be equal. So the number of columns from the first one needs to be equal to number of the rows of the second one. That's the first step, okay? When you make sure that that is correct, then we see we go one more step and say, okay, now we can multiply these two matrices. What would be the dimensions of the product matrix? In other words, now that A can be multiplied to B, what would be the product of the number of rows and number of columns of A, B? So this is what we have. The number of rows of product is equal to number of rows of the first matrix. And the number of columns of the product is equal to number of columns of the second one. The second matrix, let me write matrix. In other words, if we first make sure that m by n can be multiplied to k by l by just saying that n is equal to k, when this works, the product is going to be a matrix with the number of, you pick the first row and the second column. In other words, the number of rows of the product is equal to number of rows of the first matrix, and number of columns of the product is equal to number of columns of the second matrix. So this goes forward and this goes here. Very well. Now we know that it is, when it is defined, what would be the dimensions. How about the entries? So entries, let me write this in black. Entries of the product matrix. So I have to give you one by one. How do you do how do you find the ijth entry of the product? Well, you see the first, you pick the ith row of the first matrix, and you pick the jth column of the second one. Since the product is well defined, that means that they will have the row and the column, the row of the first one and the column of the second one, these will have the same number of components. You take them as matrix, as vector, and find their dot product. In other words, you multiply the corresponding entries and then add them. Okay, we will do some examples and you'll see how does it work. But for now, keep this in mind. ijth entry of product is I rows of the first, jth column of the second one, find the dot product. Before I go for the examples, let's do some remarks. First remark is that if the compatibility doesn't work, the product is not defined. So if the compatibility fails, then the product, the matrix multiplication is not defined. The whole thing is not defined. The second thing is that this compatibility condition basically makes possible this dot product to happen. So remark to compatibility condition makes the components of rows of the first one equal to number of components of equal to the number of components of the columns of the second one. So that's why we can take them as two vectors coming from the same dimensions, and we can multiply them. We can find the dot product. The result would be one number, and we go and use those ones, put all these entries in, and find the product matrix. Let's do examples. Remember three things: the compatibility condition we have to check, then the dimension, and then the entries of the product matrix. Okay. Here I have three matrices, A, B, and C. Well, A is 2 by 3 matrix, B is 2 by 2, and C is a 2 by 1. Now we want to find A, B. The first thing is compatibility, yes. So A is 2 by 3, B is 2 by 2. The two closed indices are not equal. In other words, the number of columns of A, the first one, is equal to 3, and the number of rows of the second one, B, is equal to 2. these two are not equal, that means that A, B is not defined. And that's it. Well, it's not defined and we cannot compute it. We cannot compute anything. How about BA? Well, B is a 2 by 2 and A is 2 by 3. Two close by entries are the same. That's very nice. That means that, well, number of columns of the first matrix, which is B in this case, equals to number of rows of the second one, which is A. And well, when they are the same, you basically ignore those guys, and then BA is going to be a matrix of 2 by 3. 2 rows, 3 columns. 2 rows, 3 columns, now we have to find it, yes? 2 rows, we have to find 6 entries. What would be? So let me call this product as C. C1, 1, C 2, 1. We have to find C1, 2, C2, 2, and then C 1, 3, and C2, 3. Yes. So to find the ij entry, we pick the ith row of the first one and jth column of the second one. Here, B, pick the first row of row of the first entry. This is 1. And then we dot product it to the first column of the second one, which is A. What does this mean? The first row here is what? First row of B is 1, 2. And then we find dot product of that and the first column, which is 1 column of. This means that we have 1 times 1 plus 2 times 1, and then you add, you get 3. Yes. So that's the first entry. 1 entry. How about 1 2 entry? Pick the first row of B 1 2 dot to second column of A, and this gives us 1 times 2 plus 2 times negative 2, which together is negative 2. I will do this one. First row of the first one, which is B and 1 2, dot product the third column. This is the third column. This is 1 times 3 plus 2 times 0, and this gives us just 3. And 2 1, well, the second row is 0 1 dot the first column 1 1, and that gives us 0 times 1 plus 1 times 1, which is 1. Let me get some space here. And here C2 2 is the second row of B 0 1 dot the second column of A 2 and negative 2. This gives us 0 times 2 plus 1 times negative 2, and that is negative 2. And the last one is 0 1 dot 3 0. This gives us 0 times 3 plus 1 times 0, which is 0. In other words, the matrix BA, which is supposed to be a matrix with 2 rows and 3 columns, will have the first row 3, negative 2, 3. I have already computed them. I'm just writing them here, and 0. That's BA. First compatibility, then dimensions, and then entries, yes? How about BC? BC, we have to first check the compatibility. B is 2 by 2, and C was what? C was 2 by 1. 2 by 1. The closer ones are the same, that means they are compatible, and the result is going to be, BC is going to be 2 by 1. The number of rows comes from the number of rows of the first one. Number of columns comes from the number of columns of the second one. 2 by 1 matrix. So 2 by 1 will have two entries, yes? The first row, first column entry, and the second row, first column entry of the product. What do we do for this one? Well, we have to pick the first row of the first one, which is B, and dot to the first column of the second, which is C. So the first row, look there, it is 1, 2. And the second, the first column of C is 1, 2. This gives us 1 times 1 plus 2 times 2, which is 5. How about this other one? Well, for this one, we have to pick the second row of the first matrix and dot product with the first column of C. So this is 0, 1 dot 1, 2. That gives us 0 times 1 plus 1 times 2, which is 2. This tells us what? This says that, well, BC, which is going to have 2 rows, 1 column, have these entries, 2 and 1. 1, 1 entry is 5. 2, 1 entry is 2. Okay? How about BC? Let me copy this thing and bring it down so that we see it right there. Copy. And just get more space here. And this is paste. Okay. How about AC? Okay, A is 2 by 3. Oh, C is 2 by 1. You see, the number of columns of the first one is not equal to number of rows of this one. This is not compatible, means that AC is not defined. So matrix product or matrix multiplication takes a little bit time. You have to practice and get all the things correct when you're doing the work.